English with Astronomy, Episode 12. Let's shift from planets to the other residents of the solar system.
Comets, asteroids, and dwarf planets. That's what's next.
Perfect. The mic is yours.
The next episode is called The Small Worlds of the Solar System. The 8 large planets are only the most visible residents of the solar system. Between their orbits and far beyond, countless small bodies are scattered: asteroids, comets, dwarf planets, and meteoroids. These wanderers are fragments of the past, witnesses to the birth of the solar system. They preserve memories of the distant time when a cloud of gas and dust swirled around the young sun. Between the orbits of Mars and Jupiter lies a vast region populated by rocky bodies, the main asteroid belt. Millions of irregular fragments circle the sun there, from dust grains to mountain-sized rocks. Long ago, another planet might have formed in that zone, but Jupiter's gravity kept stirring and colliding the pieces, preventing them from merging. The largest resident is Ceres, rounded by its own gravity and classed as a dwarf planet. After Ceres come Vesta, Pallas, and Hygiea, big asteroids with their own stories. Vesta bears a giant impact scar that almost shattered it. Many asteroids are lumpy boulders slowly tumbling through space. Some even travel as binary pairs, orbiting a common center. Not all asteroids stay obediently in the belt. Some wander onto paths that cross planetary orbits. These near-Earth asteroids pose a potential hazard. A large impact can be catastrophic. About 65 million years ago, such a collision helped wipe out the dinosaurs. Astronomers now track hazardous objects with great care. Comets are very different travelers. Icy bodies mixed with dust and rock, often called dirty snowballs. Most of the time, they linger in the cold outskirts, near absolute zero. But when a comet swings inward, the sun's heat turns ice to vapor. A glowing coma forms and a magnificent tail unfolds, sometimes tens of millions of kilometers long. A comet usually carries 2 tails. Dust is pushed back by sunlight, while ionized gas is driven by the solar wind. Both tails point away from the sun, so a retreating comet can seem to fly tail first. In the past, bright comets were read as omens. The most famous, Halley's Comet, returns roughly every 76 years. Comets arrive from 2 distant reservoirs. Short-period comets come from the Kuiper belt beyond Neptune, where thousands of icy bodies drift, the leftover building blocks of the outer planets. Long-period comets originate in the even more distant Oort cloud, a vast spherical shell that may hold trillions of dormant comets, nudged sunward by passing stars. The Kuiper belt also hosts dwarf planets. Pluto, considered the 9th planet until 2006, joined a new category when many similar bodies were found. A dwarf planet is massive enough to be rounded by gravity, but not massive enough to clear its orbit. Pluto is smaller than our moon and has a thin atmosphere and 5 moons. The largest, Charon, is so big that the pair forms a near-binary system. When New Horizons flew past, Pluto revealed icy mountains, nitrogen plains, and perhaps an underground ocean. There are others: Eris, slightly smaller than Pluto but more massive; Haumea, stretched like a melon and spinning fast; Makemake, roaming the far fringes; and in the asteroid belt, Ceres, our inner dwarf planet. When asteroids or comets shed material, they leave debris streams along their orbits. When Earth plows through a stream, tiny grains burn in our atmosphere as meteors or shooting stars. A few times a year, we cross especially dense trails, producing meteor showers with dozens or hundreds per hour. The Perseids in August, Geminis in December, Leonids in November. Sometimes larger fragments arrive, pieces of asteroids tens of centimeters across or more. these don't burn up completely and fall to the ground as meteorites. Scientists study them closely. Meteorites preserve primordial solar system material, unchanged for billions of years. Some carry organic compounds and even amino acids, hinting that impacts may have delivered water and chemistry to early Earth. The small worlds of the solar system aren't mere debris. They're an archive of our system's early history and a key to how a remarkable world like Earth emerged from the primordial nebula. And one day, we may mine asteroids or tap cometary ice to supply distant space stations. These modest neighbors could play a vital role in the future of space exploration. Your turn for questions, Jim.
Let's go. First, where is the main asteroid belt located and what is it made of? Second, what are comets and how do they get their tails? Third, what do Ceres and Pluto have in common? Fourth, how are meteors and meteorites different? Fifth, what causes meteor showers? And now, my recap. Between and beyond the planets, space is crowded with the leftovers of creation. Asteroids, comets, dwarf planets, meteoroids, the solar system's spare parts drifting through the dark. Start with the main belt between Mars and Jupiter, millions of rocky fragments on intersecting tracks. Ceres is big enough to round itself, a dwarf planet, while Vesta, Pallas, and Hygiea wear the scars of ancient smash-ups. Some asteroids even come as binaries, two rocks orbiting a shared center. A few wander inward as near-Earth objects. That dinosaur-scale impact, a reminder why we keep close tabs on them. Comets are the drama queens, dirty snowballs that wake up in sunlight. As they heat, gas and dust bloom into a glowing coma, and twin tails unfurl, dust and ion tails, both pushed away from the sun. The most famous repeat visitor, Halley's Comet, loops back about every 76 years. Where do they come from? Short-period comets arrive from the Kuiper belt beyond Neptune. Farther out lies the Oort cloud, a spherical deep freeze feeding long-period comets. The Kuiper belt isn't just for comets, it hosts dwarf planets too. Pluto and its big partner, Charon, nearly a binary pair, plus Eris, Haumea, and Makemake. Dwarf planet means rounded by its own gravity, but not dominant enough to clear its orbit. And when New Horizons flew past Pluto, the little world proved anything but simple. Icy mountains, broad nitrogen plains, and hints of an ocean below. As comets and asteroids shed debris, they leave streams of dust along their orbits. When Earth plows through those streams, the sky sprinkles meteors. The Perseids, Geminids, Leonids, and more. Bigger pieces survive the plunge and land as meteorites, time capsules from the solar system's youth. In some, we find organics and amino acids, clues that impacts may have delivered water and chemistry to early Earth. These small worlds are our archives and our future toolkit. They preserve the record of how the solar system formed, and one day they might supply fuel, metals, and water for missions pushing far beyond home. That's it for today. Let's sum it up.
Today we explored the big and small bodies of the solar system. We started with the terrestrial planets, compared similarities and differences among the gas giants, and finished with comets, asteroids, and dwarf planets.
Space is full of remarkable, diverse worlds, and we'll cover many more in future episodes. For now, stay curious and keep discovering. See you next time.
Look up at the stars more often. It's beautiful. Bye, everyone.